Okay, so this is day 2 of verifying. This day was intended for you guys to have mostly as a work day. And for me, really just to walk around the room and make sure that I can answer questions as you guys were working. So try not to use this as a day where you're just listening to me go step by step by step, but rather that you are trying and you're using the 50-minute period to work on it, check your answers if you need to. Okay, so I'm going to record going through every single problem and explaining it. So what I would suggest is that you pause it, you try a problem, you can fast forward to the end and check your answer, check and make sure that we have about the same number of steps. If you have less steps than mine, then odds are you're probably skipping something that you shouldn't. In some cases, it's okay. But if you have more steps than me, then that's probably okay. That probably means that you're stepping out and showing more than you need to, but that is definitely preferred than skipping steps. Okay, remember, don't skip. So, like I said, at any point, you can unpause and watch, and I'll explain everything, but you can feel free to fast forward. You know, try the problem, fast forward to the answer. If you're good, move on, and just kind of use this as like a check and as a work and check. Okay, so number one, step number one, make sure you have out the written out the steps and you're writing step 1, step 2. Try to keep your work organized. This is the side that I want to manipulate. Okay, I'm going to distribute. So 1 times 1 up here is 1. I can see that this is a sum and difference, so this is going to give me a minus sine x, and this is going to be a positive sine x, which cancels. So I'm not even going to write that out. Feel free. If you want to, though, you can. My last step is going to be multiplying these two together, which gives me a minus sine squared x over cosine squared x. Okay, that numerator, I can change it to cosine squared x over cosine squared x. That can be rewritten as 1, which I can see is that right side, so that equals 1, and I'm done. Okay, you should always be ending the problem by showing that one side equals the other. Okay. Number 2 over here, I'm going to manipulate this side much easier. So my first step, I can change the numerator. 1 minus cosine squared theta is sine squared theta. Notice in this case, I'm using theta instead of x. Just make sure you are consistent with whatever's in the problem. That's going to be over sine theta, cosine theta. Okay. I can cancel one of the sine squareds in the numerator with the denominator. So that's going to give me sine theta over cosine theta. Sine over cosine is y over x, which means it's tangent. So this simplifies to tangent theta, which is what I was trying to prove. So that's equal to the right side of tangent theta. So I verified. Okay. These first 4 shouldn't be too bad. They were meant as the warm-up. Okay, this side is definitely more difficult than just sine squared. So my first step, I can see right here that I have one term and that I have another term. I can see that both of them have tangent squared. So I'm going to actually factor that out. So that's going to be my GCF. So tangent squared x, when I factor that out of here, I'm left with 1. When I factor it out of this term, it's going to cancel, leaving me with a minus sine squared x. Okay. This is going to stay tangent squared x. 1 minus sine squared becomes cosine squared x. And that's not the right side, so I got to keep working. I'm going to change tangent into sine squared x over cosine squared x. Make sure they're both squared. Times cosine squared x over 1. I can see that these cancel right here, which is going to leave me with sine squared x over 1, or just sine squared x, which is what I was trying to prove. So there we go. All right. Over here, again, the left side, just for formatting reasons, the left side's easier to do. But every now and then I might switch on you. All right, so first step here, let's see. I'm going to break up, let's see. There's a couple ways that you could go about this. I could break up this sine squared x, but that's just going to end up changing it into a tangent. So I'm actually going to get a common denominator here. So I'm going to do this. Since they're already a sine and cosine, um, there's really no need to manipulate it anymore. I just really want to get a common denominator at this point. So I need to get a common denominator of cosine, which means I have to multiply by cosine x over cosine x. So this fraction is going to stay the same. I'm going to add cosine squared x over cosine x. Okay, because I have a common denominator, I can now add the numerators, which gives me sine squared x plus cosine squared x over cosine x. My numerator can change since it's sine squared x plus cosine squared x, that's 1. So I can change that to 1 over cosine x, which means 1 over cosine x is secant x. And that's what I was trying to prove. So 4 steps, and I'm done. Okay, so I'd say out of those 4 problems, maybe hopefully 3 of them were pretty decent. Maybe the first 3 weren't too bad. Maybe this one with the common denominator was a little bit harder, but 3 out of 4 I'd say are pretty good. Okay, and if it takes you a while to work through them, it's okay. You'll get quicker. Simplifying will become easier. Okay, I was intending to go through these 2 with you in class, so feel free to go along with me, or again, pause and then try it on your own. Okay. All right, in number 5, it's kind of tricky to see which side to manipulate since they both look kind of complicated. And really, you can't go wrong with either side that you choose. I'm going to do the left side here just to stay consistent with the left side, but really, you could do either or, and I'll actually kind of show you. So here's what you want to do. Sine squared x minus cosine squared x is not 1, right? It's not this up here. That was a plus. It's got to be a plus sign in order to be 1. That minus sign does not work because the sine square is still positive and that's negative, but I need both of them to be positive. Okay, but what I can do is I can rewrite this. So I can say that this right here is 1 minus cosine squared x, and then I can subtract the other cosine squared x. And then in my second step, notice that I have 3 terms here, and I can actually combine because these are alike. So this is going to give me 1 minus. If I have a negative 1, notice this is a 1 right here, and that's a 1. That means I have negative 2 cosine squared x. And notice that's what I was trying to prove. So then in 2 short steps, I'm done. Okay, just to give you an idea, I could have chosen the right side, and if I did, I would have left the left side blank and I would have said equals. I could have changed that cosine squared, and I could have said 1 minus 2, and then replace that cosine squared with 1 minus sine squared x. I should have to make sure that I create the distributive property here. So then my second step would have been to distribute this negative 2, which gives me negative 2. Negative times negative makes it a positive 2 sine squared x. Okay. And then I would have had a step 3, which would have been 1 minus 2, which is negative 1, plus 2 sine squared x. You can see at this point I'm kind of running into a problem where there's not much more that I can do with this. Sine squared I could change back into cosine squared, but that's where I started. So this is where if you try it this way, you'd probably be like, well, nothing's really happening here. So I'd kind of cross this off, and then I'd go back to trying the other side like we did to begin with. Okay, and that happens sometimes. Sometimes you start and it's just not working. That's okay. Okay. Number 6 over here. The left side is definitely the more complicated of the two sides. We're actually going to have to, it's going to take a little bit of writing here. We're going to actually have to expand these. So remember, if we're squaring something, we cannot do this because of the addition. Okay, so we're actually going to expand. We're going to rewrite this, and we're going to say this is cosine x plus sine x times cosine x plus sine x. Okay, and then over here, we're going to say plus cosine x minus sine x times cosine x minus sine x. Okay, so the first step is really just expanding so that we can distribute. Our second step, we're going to distribute, so that's going to give me cosine squared x. And then I get here, and I get plus cosine x sine x. Try not to lose those x's. I get the same thing here, so plus, and I'm just going to rewrite, oh well, actually I'm going to write sine x, cosine x, and then here I'm going to get plus sine squared x. And then I ran out of room here, so I'm just going to now work on the next line. This times this gives me plus cosine squared x. This gives me minus cosine x sine x. This gives me minus sine x cosine x. And then this gives me plus sine squared x. So be careful with your signs, positives versus negatives. Okay, so that's a lot of terms right there. I have 8 terms that I'm going to combine for my step 3. All right, notice that this right here is a positive cosine x sine x, and this is a negative. So this cancels with this, and this cancels with this. Really, they're all 4 the same thing, 2 positives, 2 negatives, so they all cancel out. Okay, look to see if I have any other like terms. I have a cosine squared and a cosine squared, so that means I have 2 of them. So I have 2 cosine squared x. Over here, I have 2 of these as well, so plus 2 sine squared x. I have a 2. I need to get rid of somehow those cosines and sines so that I can get just down to the 2. What I can do is, because they both have a 2, I can factor it out. So if I factor out a 2, if I factor out a 2, I'll be left with a cosine squared x plus sine squared x. Okay, and if you remember in the one of the examples that we had covered already, cosine squared x plus sine squared x is one of your most important identities, and it's 1. And I would really make sure that you write this step out. It's really important that you write this and you show that you're understanding that this is an identity, that it's 1. And then in my 6th step, I'm going to say that that gives me 2, which equals 2. And now I'm done. Okay, so a lot of distributing. And that's it. So let's move on to the next side. At this point, these 4, I would really try to make sure that you do them on your own and check your answer. If you get stuck, then obviously, by all means, watch me, listen to me, and I'll go through step by step, and then hopefully you can figure out where you're making a mistake at. Okay. So left side here is the best side to work with. So step 1, make sure that, again, we're numbering our steps. And that we are keeping things as organized as possible. So number. Let's see, I have 2 terms here. Neither of them have any like terms, so I can't factor anything out, which means then I want to change things into sines and cosines. So cotangent can be changed to cosine theta over sine theta times cosine theta over 1 plus sine theta, and I'm going to change this over 1 too, so that I make it a fraction as well. Okay. Nothing cancels over here, but I can multiply, and I can get cosine squared theta over sine theta plus sine theta over 1. Okay, they do not have common denominators, so I cannot add them, but I can make them have a common denominator if I multiply this by sine theta over sine theta. Okay, so that's going to give me, this fraction is going to stay the same. This one's going to become sine squared theta over sine theta, and make sure that we're writing sine squared theta, not sine theta squared. Okay, that's an important step because we're showing like terms. Okay, now I can add them, which gives me cosine squared theta plus sine squared theta over sine theta. Right. My next step, I can change my numerator to 1, that really important identity of cosine squared theta plus sine squared theta over sine theta. And that can be rewritten as cosecant theta, which is what I was trying to prove. So everybody should be ending theirs the same way. And hopefully we had about 6 steps. Okay, again, if you have less than 6 steps, look back, you're probably skipping something that I'd want to see and that you should be writing out. Okay. Left side is more complicated than the right side. If you got stuck on this one, odds are you did not see that you can factor this. Be very careful. You cannot say that tangent squared and tangent cancels and -1 divided by 1 is 1. Okay, you're going to end up doing the wrong algebra to get the right answer, but doing the wrong algebra is obviously wrong. So what you need to do is recognize that this is a sum and difference problem, right? It looks very similar to x squared minus 1 if we were to get rid of that tangent. Okay, and then remember we did this to factor sum and difference. So we're going to do the same thing here. We're going to take the square root. We're going to take the square root. When I factor this, I want to make sure that I set up 2 sets of parentheses. Okay, and my goal is to hopefully get that one of them looks like 1 plus tangent x. That way something can cancel. Don't lose this plus 1 on the outside. It's easy to lose that. So the square root of tangent squared x is tangent x. 1 has to be plus, 1 has to be minus in order for it to be sum and difference. Square root of 1 is 1, so 1 is 1 and 1. Okay, now they're written in different orders. But addition can be flip-flopped. So tangent x plus 1 is the same as 1 plus tangent x, so these cancel, which means my step 2 is tangent x minus 1 plus 1, which means then my third step, I'm left with just tangent x, okay, which is not 1 over cotangent x. Typically when we get to here, we are done, but we need to make this look like that. And that's really just its identity. So tangent x is the same as 1 over cotangent x, which is what we wanted to prove. Okay. That's kind of like if we got down to an answer like cosine x, that's the same as 1 over secant x. Not a common identity that we use, but we can use it every now and then. Okay. All right, we got 2 more. Left side is easier to manipulate than the right side. So let's see, step 1. So I can rewrite tangent squared x. So this one's kind of interesting. I can rewrite tangent squared x. Okay, I can rewrite it as, let's say at this point, you should have your identities known pretty well, but let's say you forgot what this identity was, and you know that tangent squared x can be rewritten as something you just forgot. Here's one way to remember it. Or let's say you get stuck, and here's one way you can kind of figure it out. Some of your really important property is that cosine squared x plus sine squared x equals 1. That's the equation of the unit circle. Okay, x squared plus y squared equals 1. From here, we can manipulate this. If I divide this whole thing by cosine squared x, cosine squared divided by cosine squared is 1, plus sine over cosine is tangent squared x 1 divided by cosine squared is secant squared. Okay, so I can figure out what that identity is just by going back to here and dividing by either cosine squared or sine squared. In this case, cosine squared was the right one to divide by. If I subtract 1 to the other side, that means that tangent squared x is equal to secant squared x minus 1. Okay, and honestly, sometimes I forget the properties too. And I always just go back to here and I just figure it out based off of that property where it came from. Okay, so that means that I can replace the numerator with secant squared x minus 1 over secant x plus 1 and then a plus 1 on the outside. So it's kind of odd because I actually made the numerator look more complicated, but by doing that, it actually now looks very similar to this up here. Instead of tangent, though, it's secant. So actually, we just created a problem where we can factor using sum and difference. So I'm going to set up my 2 sets of parentheses. Try to give myself some room. And then I'm going to hope that one of them is secant x, because then secant x plus 1, because then something will cancel. Okay, so the square root of secant squared x is secant x. The square root of 1 makes one of these plus 1 and one of them minus 1. And then don't lose that plus 1 on the outside here. Okay, I can see that these two cancel, which means in step 3, I'm left with secant x minus 1 plus 1. Okay, which means then I'm left with just secant x, which is what I wanted. Okay, so really this was the same thing as number 8. It just started differently because I had to use an identity to make it look the same, and then I factored using sum and difference. I canceled, and then I was done. Okay, so slight manipulation, but same idea. Okay, this one seems to have a little bit more going on with it, so I'm going to work with this one. Notice that this is a sine squared. So this looks like your ax squared term. This is just a sine, so this looks like your bx term, and this is just a constant, so that's your c. Okay, that means that this is a trinomial. When you see a trinomial, you should be thinking factor. So my first step, I'm going to set up my parentheses, and I'm going to give myself a lot of room here. I'm going to hope that somewhere along the way I can get a cosine squared x. If you take a look at what you have, though, the numerator has sine and sine, which means that when I factor, I'm for sure not going to get a cosine squared, but we're going to eventually figure out where that's coming from. Okay, so if this is a 3 sine squared, that means that one of these has to be a 3 sine x, and then the other one is just a sine x. Since there's a plus sign here and a plus sign here, I can fill in a plus and a plus. Okay, now be very careful with this too. Okay, the factors of 2 are obviously just 1 and 2, or 1 times 2. But this 3 is going to affect whatever I put over here. So if I put a 2 here, that means that this is actually a 6, which is more than my 5. So I can't put a 2 there, but I can put a 2 here and a 1 here. And then 3 times 1 is 3, and 2 times 1 is 2, which is giving me my 5. Okay. One way to approach this factoring, if that's kind of confusing, is really just to get rid of your signs. And you could write off to the side 3x squared plus 5x plus 2. And when you factored that, you would have 3x and x. You would have a 2 here and a 1 here. And you can see that that gives you 3 plus 2 more is 5. In your steps, you're obviously going to have to write your sign, but it might help to write this off to the side to help you with this. And then notice that instead of 3x, it's 3 sine x. Instead of x, it's sine x. Okay. Now, nothing canceled because obviously there's a sine here and a cosine squared. But I can change cosine squared to make it look like a sine. So I'm going to leave my numerator the same. I'm going to write 3 sine x plus 2 sine x plus 1. And my denominator is an identity which I can rewrite as 1 minus sine squared x. Okay, remember anytime you have cosine squared or sine squared, it's always 1 minus whatever the other one is. Okay, that means that if you have cosine squared or if you have sine squared, it's always 1 minus. And since this is cosine, it would be sine squared. And since this is sine squared, it would be cosine squared. Okay, so one way to remember. All right, so now we just changed it, but again, it didn't cancel. So if you remember back to yesterday when I was talking about factoring, I said that typically when you factor, something cancels. Well, it didn't. Nothing canceled in the first steps because I had sine and I had cosine. I changed cosine squared into sine squared, and nothing still canceled. But this right here, 1 minus sine squared x, is very similar to number 8 and 9. It's a sum and difference problem. I can take the square root of both of these. So my numerator is going to stay the same. My denominator, the square root of 1 is 1. 1's plus, 1's minus. The square root of sine squared is sine. So sine x and sine x. Okay, and now after all of that manipulation, I can now see that sine x plus 1 is the same as 1 plus sine x. Different order, but addition doesn't matter. So those cancel, leaving me with 3 sine x plus 2 over 1 minus sine x. And that's what I was trying to prove. So I'm going to rewrite this. And then I'm done. Okay, let's see here. So if you really think about the last 3 problems, they were really the same thing, just a different slight manipulation of each. In number 8, we factored a sum and difference. We really just did it right from the beginning. In number 9, we factored a sum and difference, but we had to use this identity right here in order to get that first step, which then gave us the sum and difference. In the last problem, we factored a trinomial. We used an identity to rewrite cosine squared x. We used that identity to write it as a sum and difference, and then something finally canceled. So a little bit more manipulation. Okay, so things to remember as you're working. Make sure that you number your steps. Try to keep it as logical as possible. We really want to make sure that we're working vertically and we're not jumping all over the place, but numbering is going to help if we do have to and we run out of space somewhere. Okay, show each and every step. Your homework. I don't think there's anything crazy about your homework. I have the first one circled, so that probably means I wanted to go over it, so I'm going to go over it real quick. Yeah, so just more of the same, some more practice. Oh, I know, I definitely want to go over this first one. So in number 1 here, this side is a little bit more complicated than the other side, given the fact that you got a cosine and a sine and not just a sine. It kind of looks like a problem that we did in our notes, actually. The fact that these are 4s, this is a sum and difference problem. Okay, because I can take the square root of both of these, and there's a first term and a last term, no middle term. There's no trinomial. So I can factor this. I can say the square root of cosine to the 4th x is cosine squared x. 1's plus, 1's minus. The square root of sine to the 4th is sine squared x. Which does not look like the right side, but I can keep manipulating this. Okay, let's see. I want my answer to have a sign. So you really want to pay attention to what you want your answer to look like. So if I want it to have a sign, I don't want to change the signs. I want to make the cosines look like the signs. Since cosine squared x, I'm just going to write this off to the side so you can see it. Cosine squared x is 1 minus sine squared x. So I can replace all of those cosine squared x. So instead of cosine squared x, I can say 1 minus sine squared x plus sine squared x. And then over here, I can replace this one too with 1 minus sine squared x minus sine squared x. My next step, I can combine like terms. Actually, this one here and here cancel, leaving me, I'm going to erase this, leaving me in this one with just a 1 times, over here this is going to change to 1 minus 2. So if I have 2 of these, 2 sine squared x. And that's what I was trying to prove. So I'm actually going to have a 4-step here so that I know that. So I'm showing that 1 times this is leaving me with 1 minus 2 sine squared x, which equals 1 minus 2 sine squared x. And I'm done. Okay, everything else should look pretty similar to something that we've done. Okay, if you need more work, feel free to work on a separate sheet of paper. Just don't lose it. All right, I'll see you on Friday. See you then tomorrow.